Hello students, today I am going to discuss on climate change and cryosphere. Students, the cryosphere describes to all the components of the global system in which water appears in frozen or semi-frozen state for an elongated period. It includes regions of high land where seasonal snow covers glaciers and the icebergs over polar ocean and permafrost regions. These components are distributed across high latitude ocean and mountains of polar regions to cold mid latitude region. Although the cryosphere stretches a relatively small part over the earth of the surface compared to areas covered by ocean and continent, it exerts an extremely large influence on the earth's climate system through its continuous exchange between all the sphere of earth like atmosphere, hydrosphere, biosphere and lithosphere. A significant character of the cryosphere is its high sensitivity to temperature increase. A slight change in air or ocean temperature can produce significant variation in the level, thickness and period of the snow and ice formation. This critical sensitivity makes the cryosphere an indicator of climate variability and long-term climate change. Over geological time scales, the advancement of ice sheets have reshaped global sea level, atmospheric circulation pattern and ocean ecosystems. In the present times, the rate and magnitude of the cryosphere exchange are extraordinary in the context of human history, which reflecting the rapid pace of anthropogenic contribution in global warming. Students, cryosphere plays an important role in maintaining Earth's energy balance. It reflects back a large portion of incoming solar radiation due to their high albedo, thereby cooling the planet. So, you can understand its importance. When snow and ice melts, darker land and ocean surface are exposed, which absorb more solar energy and enhances warming. The cryosphere is an important store of fresh water. Glaciers along with ice sheets together contain nearly 70% of the world freshwater reserves, while seasonal snow cover acts as a natural reservoir which added meltwater gradually. Many major river systems originating in high mountain regions are perennial in nature and these depends heavily on snow and glacial melt. Accordingly, the cryosphere plays a vital role in global and regional hydrological cycle, changing water availability for various natural human uses. The cryosphere strongly affects the global sea level. Thawing of glaciers and ice sheets add water to the ocean, while warming seawater expands through thermal expansion. Increasing sea level have already influences the frequency of coastal flooding and erosion. Trends in cryosphere changes majority involving the Greenland and Antarctic ice sheets are posed to long-term risk of extensive sea level rise. Recent climate change, primarily due to the influence of anthropogenic greenhouse gases emissions, is exerting exceptional pressure on cryosphere. Extreme warming has led to continuous decline of glacial and thawing of permafrost region. These noticeable and often severe changes make the cryosphere one of the most significant indicator of global climate change. Understanding the cryosphere role in maintaining Earth vitality is therefore essential for understanding climate changing aspects which is involved in future risk to the humanity to develop effective modification and adaptation strategies in a contemporary scenario of climate change. Hello students, the main objectives of this lesson are to elaborate the concept and component of the cryosphere, to analyze the role of the cryosphere in regulating Earth's energy balance, to examine the influence of climate change on different cryospheric components, and to evaluate the effects of cryosphere change on the sea level rise, water resources, ecosystems and human society. Students, let me explain to you the component of the cryosphere. The cryosphere system is a diverse and interconnected with all forms of frozen water observed on the Earth's surface. These factors vary widely in their areal extent, physical characteristic and temporal characteristic to climate change. Regardless of these differences, they are directly intertwined through Earth's climate and hydrological systems, which jointly exerts a deep effect on Earth energy exchange, water accessibility and human civilization. As frozen water respond fast to temperature variations, the cryosphere shows one of the most sensitive indicator of warming of climate. Recurring snow cover is the most prevalent and dynamic component of the cryosphere, appearing seasonally through much of the higher elevation of northern hemisphere. It plays a significant role in regulating surface reflectance, with newly deposited snow reflect more proportion of incoming solar radiation and helps in lowering the surface temperature because it absorbs all the incoming solar radiation. Snow surface also as an insulation defending soil and vegetation from extreme cold and support their biological and chemical processes beneath the surface. Hydrologically, recurring snow serves as a provisional source of fresh water storage, delivering water only during the warmer months to maintain river-based flows and recharge groundwater. So, you can understand the significance of cryosphere from all perspectives. Changes in the timing and duration of the snow have direct implication for water availability and flood risk. Glaciers and ice caps formed by the compacted snow. They store a lot of fresh water and help river flows by releasing meltwater during dry seasons. Increasing temperature are causing them to shrink and lose their ability to supply fresh water to the perennial river. The large ice sheet in Greenland and Antarctica are significant for affecting the sea level rises. Even small changes in their size can cause submergence of big cities, and the effect can be witnessed for centuries. Icebergs on ocean ice and permafrost region further highlight the cryosphere's climatic importance. Sea ice control, heat exchange between the ocean and atmosphere and control weather and ocean circulation, while permafrost stores huge amount of frozen free carbon. Thawing permafrost releases greenhouse gases, establishing powerful feedback that increases the speed of warming. Concurrently, cryosphere components cover about 10 to 15% of Earth's surface and store nearly 70% of the global fresh water. Their rapid change under climate change highlights the central role of the cryosphere in modeling Earth's present and future climate. Now, let me explain to you the cryosphere impact on the Earth's energy balance. One of the most essential climatic function of cryosphere is its role in regulating the Earth's heat energy balance. The universal climatic system is governed by the balance between incoming solar radiation and outgoing terrestrial radiation. Activities that alter the incoming and outgoing energy is redistributed across the Earth's surface has considerable consequences over the global and regional level climates. Through its distinctive physical properties and extensive horizontal coverage over the poles and high altitude regions, the cryosphere applies a convincing control over this equilibrium and plays an important role in maintaining climatic stability. A distinctive feature of cryosphere surface is their high albedo. Now, what is albedo? Albedo refers to the proportion of incoming solar radiation that is reflected back into the space rather than absorbed by the surface. Fresh snow can reflect only 80 to 90% of the incoming solar radiation. On the other hand, glacier ice and sea ice also have substantially greater albedo value than open ocean and bare land. Huge areas of the polar region and high mountainous are covered by snow and ice. The cryosphere effectively acts as a terrestrial mirror, limiting heat absorption and helping to maintain reduced global temperatures. High altitude area already accept relatively lower solar radiation due to the low angle of the sun, and extensive ice and snow cover further limit heat absorption. As a result, these areas remain cold and perform as global heat sinks. The cooling effect of the cryosphere is not restricted to the polar areas alone. It extends globally via atmospheric and ocean circulation, contributing to the overall firmness of the Earth climate system. Global climate warming is disrupting this existing energy balance. Rising atmospheric and oceanic temperature have led to widespread reduction in snow cover, thinning of sea ice, retreat of glaciers and surface melting of ice sheets.